So now let's investigate the next quanta, isotopic spin. And the isotopic spin for the higher generation particles should be 0. So let's see what we have for the S quark. First, looking at the generic U, and we see we have, for each of the rishons, we have 1/6 for a sum of 1/2 plus 1/2. But if we look at scalar boson minus, then we see we have a minus 1/6 and a minus 1/3, which will give us a minus 1/2, which sum to the isotopic spin of the generic U quark will give us a 0. And of course, the particle pair contributes nothing to the isotopic spin. So, as indicated by the standard model, the isotopic spin on the S quark is 0. Now, if we look here, we can see that the emitted scalar boson minus will carry away an isotopic spin of minus 1/2. And then the vector boson and the scalar boson will contribute nothing to the isotopic spin. So if we look at the decay product of the U quark, we will see that its isotopic spin then is 1/2, since the scalar boson 0 contributes nothing to the isotopic spin. And as before, we can look at the opposite quanta on the antigeneric U and see that we have minus 1/2 and plus 1/3 on the boson plus, giving us isotopic spin of 0 on the anti-S quark. So let's take a look at flavor. So let's look at the flavor of the S quark. First, there is no flavor contribution on the rishons of the generic U quark. And the flavor contribution only comes on the prime V rishon, where we can see we have a -1, and there's no contribution of flavor on the prime NTT. So, and of course the particle-antiparticle pair make no contribution to the flavor. So the flavor for the S quark is -1, which is indicated by the standard model. And then if we look at the W boson, we can see that the scalar boson minus carries away that -1 flavor on the S quark, leaving on the U quark no flavor, since it is a first generation particle. And we can look here and see that if we look at the scalar boson plus, that we have the opposite flavor charge of +1 on the anti-S quark, which would be indicated by the standard model. These particle-antiparticle pairs here have the opposite flavor charges, so contribute nothing to the flavor charge of the anti-S. Therefore, the anti-S has a flavor charge of +1. And finally, let's look at the color charges. Look at the generic U. The color charges are given by the half semicircles, the right-handed half semicircles. For instance, here the color charge is purple, and you can see as I hover there, the actual color charge components are displayed. And so this is purple, and this is anti-purple or yellow, and then we have red. And so the color charge on this generic U, since the purple and anti-purple are yellow and anti-yellow cancel, will be red. And here we actually have blue and anti-blue, which cancel, and yellow and anti-yellow, which cancel. So the color of this S quark will be red. And then we can see what is carried away by the W boson. And again, we have the boson minus, which had no color charge because we had blue and anti-blue. And here we have a yellow T-rishon and anti-yellow prime rishon, so there's no color charge given by this boson 0. And so, and here we have a yellow and anti-yellow, so there's no color charge carried away by the W boson. But if we go back here to look at the U quark, which is now composed of a generic U and a scalar boson 0, then as before we have red color for the generic U quark, and the scalar boson 0 has yellow and anti-yellow, contributing nothing. So as it should be, we continue to have the U quark having the color yellow, just as the S quark did, since the W boson carries away no color. And the color of the antiparticle, of course, would be the opposite of red, which would be, in this case, green, as we can see, having the yellow and anti-yellow here, leaving green, and having the color charges on the boson plus and the boson 0 particle pair cancel one another out. And so in that way we can see that in the decay, the color charge, which started off as red, remains red for the decay product, which is a U quark.